I get this question all the time. How do the planets orbit the sun? And it's really a very good question because if we take a step back from the solar system and look at it from far away, everything seems to be flying around in perfect harmony with each other. The planets are orbiting the sun in ways that allow them to coexist peacefully without running into each other and causing chaos. So how do they do that? Well, let us start out by looking at why the planets stay in orbit around the sun in the first place. This is not a difficult concept to understand. We all know that the sun is massive and has a lot of gravity. If something gets too close to it, then that thing will get pulled in and destroyed. But why don't the planets fall into the sun if they're so close to it? Well, the reason is simple. It's because they ray going around the sun fast enough that their forward motion keeps them from falling in. You see, when an object moves through space, it's constantly falling towards whatever is nearby. So if you want to keep something from falling into a massive gravity well, you have to make sure that it's moving with sufficient speed. In fact, there is a very interesting relationship between how fast a planet is going and how far away from the sun it is. You see, the further away from the sun you go, the less gravity there is. So, you don't need to be going as fast to stay in orbit. The closer you get to the sun, though, the more gravity there is. So you have to go faster to stay in orbit. That's why Mercury, which is the closest planet to the sun, goes around it the fastest, and Neptune, which is the farthest planet from the sun, goes around it the slowest. But just knowing that the planets are going around the sun fast enough to stay in orbit doesn't really tell us anything about how they manage to not run into each other. After all, if they're all going in circles, then surely they must be eventually going to bump into one another, right? Well, no. That's because even though all the planets orbit on the same plane, they actually don't all orbit at the same altitude. If you could look down onto our solar system from above or below, then you would see that all of the planets orbit in a slightly tilted circle. Now, the tilt isn't very much. It's only about 7 degrees. But it's enough to mean that some planets are always higher than others. For example, Mars is closer to the sun than Jupiter, but Jupiter has a slightly higher orbit. This means that sometimes Jupiter is actually higher than Mars, even though it's farther away from the sun. Now, because the planets are going around the sun in circles, this means that they're always passing each other at roughly the same points. So if one planet is higher than another, then that means that it's also going to be passing it higher up. In other words, a planet that is higher up in its orbit will pass other planets that are lower down in its orbit. And because of the way the planets move, that means that they'll always be passing each other in such a way that they won't collide. And this brings me to something I've been wanting to talk about for a while. You see, many people seem to believe that the orbits of the planets are somehow special, that the planets are magically able to avoid colliding with each other because their orbits are perfectly safe. But that's not the case. There are plenty of places where the orbits of the planets come dangerously close to intersecting. For example, if you were standing on Earth and looked up to the sky, you would see Venus and Mars almost directly in front of you. They would appear very close to each other, so close in fact that it would be hard to tell them apart. And if you watched them for a few days, you'd see that they passed each other. But when they did, they wouldn't collide. Instead, Mars would pass in front of Venus, appearing to overtake it. And this is exactly what would happen if you swapped the positions of Venus and Mars. Mars would still pass in front of Venus because Mars was overtaking it in the first place. Of course, swapping the positions of two planets doesn't actually change anything. Mars would still orbit the Sun just as it does now, and Venus would still orbit the Sun just as it does now. It would just change what we see from our perspective here on Earth. The point is that the solar system isn't some sort of magical collision-free environment. It's simply a collection of objects that interact with each other according to the laws of physics. And those interactions just so happen to result in the planets orbiting the Sun in a relatively safe manner. So how long does it take for a planet to orbit the Sun? Well, it depends on how far away from the Sun it is. You see, the further away a planet is from the Sun, the slower it has to go in order to stay in orbit. And the slower it goes, the longer it takes to go round. For example, Mercury orbits the Sun in just 88 days because it is relatively close to the Sun and thus has to move quickly to stay in orbit. On the other hand, Neptune orbits the Sun in 165 years because it is relatively far from the Sun and thus doesn't have to move very quickly to stay in orbit. Now, there are also other factors that can affect how long it takes for a planet to orbit the Sun, such as the mass of the planet. A more massive planet will have a stronger gravitational pull, which will affect other objects in the solar system and cause them to move in slightly different ways. But these effects are usually pretty minor. For example, if you wanted to calculate how long it took for Neptune to orbit the Sun, you could just use Newton's law of universal gravitation. But if you wanted to calculate how long it took for Mars to orbit the Sun, you'd also need to take into account the gravitational effects of Jupiter and Saturn. Of course, even with these effects taken into account, it's still only a minor change. The major effect on orbital periods is the distance from the Sun. So there you have it. That's how the planets orbit the Sun. They stay in orbit because they go around the Sun fast enough to prevent themselves from falling in. And they don't collide with each other because the orbits of the planets are slightly tilted, which means that they pass each other at such a height that they never collide. As for how long it takes a planet to orbit the Sun, well, that depends on how far away from the Sun it is. The further away, the slower it goes, and the longer it takes to go round. So I hope that answers your question. And if you have any other questions, then feel free to ask in the comments below.